Welcome to the session on Unix system programming. So in this session, we are going to understand about process environment. So wherein we are going to actually understand and learn about how a main function is called when a program is executed, how a command line arguments are passed to a new program, what the typical memory layout look like, how to allocate additional memory, how the process can use environment variable, various ways for a process to terminate, and etc. So these are all the few important topics which we are going to cover under a process control. So wherein basically a process is termed as program under execution. So any program which is executing, we call it as a process. So any program under execution is what we are going to call it as a process. So among that, one important thing what we are going to begin with is a main function. We know that program execution in any programming language is going to start with the main function. Clear? So we are going to understand how this main function is going to execute in case of a C. That's what we are going to understand now. So even in C program, a program execution starts with the main function. A general prototype of a main function is as shown to you. So which accepts the two parameters. One is ARGC, the other one is ARGV. ARGC is going to have a number of arguments which are passed to it. Are passed to the main function. Wherein ARGV is going to contain actual arguments. So ARGV is a vector, it's an array which is going to contain actual arguments which is passed to the main function. And ARGC is going to contain number of arguments passed to the main function. So whenever a C program is executed by the kernel, a special startup routine is called before a main function is executed. So what kernel will do is kernel will call a special function, and this function we call it as a startup routine, and the startup routine executes before the main function, and this startup routine is marked as a starting address for the program. The startup routine will be marked as a starting address for your main or your program. And what exactly this startup routine is going to do is, the startup routine takes a value from the kernel. What kind of values it is going to take? It is going to take a value like command line arguments as well as the environment. What do you mean by environment? You will be coming to know in next sessions. But as of now, understand this. So kernel is going to provide command line arguments as well as the environment to the startup routine. So by taking these two things as an input, the startup routine is going to initiate the execution of main function. So this is how a main function is going to begin its execution. Once a main function is executed, main function will initiate the execution of all other sub-functions or the user-defined function which are provided in the program, so that the complete process is going to execute. So initially what we have understood till now is program execution will begin with the main function. But before a main function is executed, main function is initiated by the startup routine which is called by kernel. Clear? So the startup routine is going to initiate the execution of main function. So once a main function is going to execute, it will complete the execution. Once execution is completed, a main function has to terminate, or what we call it as a process has to terminate. Whenever a process needs to be terminated, there are different ways how a process is going to terminate. Probably there are 8 different ways how a process is going to terminate, or there are 2 ways how a process is going to terminate. 2 classification how a process is going to terminate. One, I call it as a normal termination. The other one, we call it as an abnormal termination. So what are all the process which is going to terminate a process normally? So what are all the process which is going, or what are all the steps which is going to terminate a process normally, if you ask me? So I can say that whenever a program is completed, whenever a main function completes its execution, it will return It will return control to the operating system, and that is what we call it as a normal termination. Return from the main function is a normal termination. Or in your program, if you are going to call for an exit function, exit function will cause a normal termination of a program. Or there is two more functions like underscore exit. If you call this function underscore exit, even this is going to cause your program to terminate normally without any problem. Or there are two more ways: return from the last thread from its start routine, or calling p thread underscore exit from the last thread. So these 2 points are related to something called as a multi-threaded programming. So we are not going to concentrate more on this multi-threaded programming as of now. Leave these 2 points. Leave these 2 points. We are going to concentrate more about this exit function as well as main function as of now. Now, if you ask me what are all the different ways how a program is going to terminate abnormally, I can say there are three ways how a program is going to terminate abnormally. One, whenever you are going to call a abort function, abort system call or abort function, or whenever there is a receipt of a signal, whenever you are going to receive, or whenever a process is going to receive a signal in order to do something, or that's going to cause an abnormal termination. Or whenever you are going to have a response of the last thread to the cancellation request, once again this is a point related to multi-threading. So these are all the different ways how a process is going to terminate abnormally. Overall, if you ask me, there are 8 different ways how a process is going to terminate. 5 ways where a process can terminate normally, 3 ways how a process can terminate abnormally. So this is how a process usually is going to terminate. Now we are going to understand much about this process termination, particularly with the exit function. The startup routine, as we already explained, the startup routine is the one which is going to begin the initiation and execution of the main function, which is called by the kernel. So the startup routine is also written so that the main function, when the main function returns, the exit function is called automatically. So suppose that this is how it will look like. A main function will be passed as a parameter to the exit function. Check it out with the prototype which is written here. So main function will be passed as an argument to the exit function. So whenever a main function completes its execution, automatically this exit function will wind up or terminate the process or terminate the main function. So this is how prototype for a main function will be written, and this code will be written by the startup routine. This code will be written by the startup routine. Clear? Now, particularly coming to this exit function, there are 3 different types of exit function which we have. Like we have a normal exit function, and we have underscore exit, and we have one more underscore exit with the uppercase, which is going to start with the uppercase letter. So all the 3 exit functions are going to terminate the process normally. This is what the similarity I can say between these 3 functions. So all 3 exit functions is going to terminate the process normally. So this is what similarity. Is there a difference between them? 100% there is a difference between these 3 exit functions. What is the difference between these 3 exit functions? If you see this underscore exit, which begins with the lowercase as well as which begins with the uppercase, these 2 functions will return to the kernel immediately. Wherein the exit function will perform certain cleanup processing and then return to the kernel. It will not just return to the kernel normally, it will clean up the process, whatever it is written in the program, then it will return to the kernel. And one more thing is, the exit function as well as underscore exit function is going to be defined in a header file stdlib standard library.h, wherein underscore exit, which begins with a lowercase, is defined in a header file unistd.h. Wherein one more similarity among these 3 functions is, all these 3 functions is going to accept in one integer value, and this integer value we call it as a status value of exit function. So what exactly the status value is, how exactly this exit function is going to run, or exit function is going to work, we'll understand with one small example. Let me write one program and explain you how this is going to work out. Uh, So now what I am going to do is I am going to write one program which is going to demonstrate how this exit function is going to work. Observe this carefully. Let me write this in a new file. Let me save this. I'll save the program as p3.c C program. Include stdlib.h. So I'm going to include a standard library.h for a program. Why? Because my exit function is defined in a header file stdlib.h. That's the reason why I'm going to include this stdlib.h here. So I'll start with a main function, regular main function, int main. Okay. I'll just include one counter, initialize it to 1. Then I'll write if before this, let me write one more function, void on exit printf this is exit handler. Just one user defined function I'm going to write. So later on I'll start with the main function, wherein in the main function I'm going to call at exit on exit not equal to 0, printf can't register on exit. I just include a new line character so that it will be easy for me to understand. Okay, let me write an infinite loop while loop. So wherein here I am going to print counter value %d comma count count, and I'm going to check if this counter value becomes equal to 5. I just call exit and status I'm going to write as 0. Then increment this counter in a while loop, and before terminating return 0. Okay, so this is my program. Look here. Okay, hope this program is visible to you. Understand this. So I had written one small program where this program is going to illustrate the difference between an exit as well as underscore exit function. So where in which I am going to write one user defined function like on exit, void on exit. What I am going to execute in this is I am just printing one message like this is an exit handler. This is an exit, and that's the message which I had printed in this on exit function, and it is a user defined function. What I am going to do in this main method is just I'll include one counter which is initialized to 1, and there is one more function called as a at exit. There is one more function called as a at exit, and what this at exit is going to do is this is going to return 0. Understand this carefully. At exit is one predefined function, and this function is going to return 0 if a program is executed normally. If a program is executed normally. If a program is not executed normally, this at exit function is going to return non-zero value. When I say non-zero value, it can be negative value or it can be positive value, whatever it may be. Apart from 0, this is going to return non-negative value whenever a function is terminated abnormally, or whenever a function is not executed properly. So what is the parameter which is accepted by this at exit is the function. So what is the function I am going to pass here? On exit is the function which I am going to pass here. Now, if at all on exit function is executed properly, if at all on exit function is executed properly, we are not going, at exit is going to return 0. At exit is going to return 0. If on exit is not going to execute properly, at exit is going to return non-zero value. So this is how it is going to work. We'll see when it is executed. We'll see. Then in a infinite loop, what I'm going to do is I'm going to display the count value, and when this count value becomes equal to 5, when the count value becomes equal to sign, I'm going to exit from the program. I'm going to exit from the program. Or if the count value is not equal to 5, I'm going to increment the count value. This is a simple C program which I had written. Now, how the process of how the exit is going to work, as well as how the underscore exit is going to work, we'll see with this example. Let me run the program and show you the output. cc p3.c. There is a mistake. Okay, it's a printf. Okay, let me execute. So program is compiled properly. There is no problem. Can anyone guess what might be the output for this program? I'll run the program. /. You can see that we got a number displayed from 1, 2, 3, 4, 5, and finally the message, this is exit handler. You can see that there is a number displayed from 1, 2, 3, 4, 5, and finally we got the message as this is exit handler. Compare this with a program. See, what happens here is a program execution begins with the main function, as I already told you. But before a main function is executed, startup routine will initiate the execution of main function. And what this startup routine will do is startup routine will put main function inside the exit function. So in other words, here I have a at exit function. This at exit function will be executed at the end of your program, not at the beginning of your program. Understand this clearly. Even though if it is written at the earlier, at exit function will execute at the end of your main function. Clear? So we are not going to get executed with this part at the initial point. So what gets executed at the initial point is the while loop. So what is present in the while loop is printing of count value. So let me put here /n so that it will be easy for us to read the output. So what happens here is count value will be printed. Initially count value is 1, and 1 will be printed, and 1 is not equal to 5. So 2 will be printed. It is an infinite loop. Count will be incremented. 3 will be printed. 4 will be printed. 5 will be printed. Once a 5 is printed, the condition becomes true here. Count value is equal to 5. When the count value is equal to 5, this exit function gets executed. When the exit function gets executed, exit function internally calls a cleanup functions to get executed. So what is the cleanup function? At exit. Understand this clearly. So exit will not terminate the process or terminate the program directly. Exit will cause the execution of at exit. So what at exit will do? At exit will call on exit. So what is there in the on exit? This is exit handler. And you say whenever I exit on exit function, message will be printed or any problem is going to occur here. So exit function, before it is going to terminate the process, it is going to call or it is going to clean up the any other procedure which is existing. So this exit function is going to call or it is going to make at exit to execute. So what at exit is going to do? At exit is going to call on exit. So on exit will execute the function. Since there is a normal execution of a function, after execution of at exit, it will return a 0. It will return a 0. So 0 not equal to 0 is a false, and because of which we are not going to get can't register on exit printed onto the screen. So what will be the output here? As you can see, counter value 1, 2, 3, 4 and 5 is displayed, as well as the message. This is exit handler, where it was present in the on exit, which was called by the at exit, which was internally called by the exit function. So this is how exit function will work. This is how exit function will work. Yav exit function, before it is going to terminate the process, it will clean up all other process which is present. So I am going to write this as underscore exit. Underscore exit. Save the program. Same program. The just thing is, instead of calling the exit function, I will write underscore exit. Now let us see what will be the output here. Compile the program, run the program. And you can see, I didn't get a message, this is exit handler, where a counter value 1, 2, 3, 4, 5 is printed. We have not got this message like this is exit handler. Why? Because this underscore exit is not going to initiate, or it is not going to clean up the exit process. Is not going to clean up the resources which are open. So this underscore exit will not initiate the execution of at exit. So it initiate agilla antandre on execute to run agalla, so that we are not going to get a message like this is the exit handler. Is that clear? So down the line, understand. Exit, before terminating the program, it will clean up the process which are open. Underscore exit, it will not clean up the process which are opened in the function. That's the difference between exit as well as underscore exit. Is that clear? Okay. So this is what we are going to we have understood about exit function as well as underscore exit as well as at exit function. Clear? Now, so we have understood about a main function. So what is the prototype of a main function? When a main function is executed, what is the routine which is initiated by the kernel? We came to know a startup routine is initiated by the kernel. What will be the prototype of a exit function when a main function is going to be called? That we saw. And we even saw what are all the different ways how a process is going to terminate. There are 5 different ways how a process can terminate normally, 3 different ways how a process can terminate abnormally. Then we particularly concentrated on a process, how the process terminating normal way, particularly with respect to exit function. So there are 3 exit functions which are going to be there for normal termination of a process: exit as well as underscore exit. So what is the difference between this exit as well as underscore exit is what we have understood in the current session. In the next session, we are going to understand about few other concepts like environment variable, environment list, command line arguments, as well as memory layout of a C program, which we will be dealing in the next session. Clear?